Institute for Production Management, which is an institute of great repute in the field of operations and maintenance. And many of us would not know, but this has been in existence since almost 1979. And the institute is promoted by a government of Orissa in collaboration with SAIL, the Steel Authority of India, L&T, and ICICI Bank. I am sincerely thankful to the leadership team of IIPM, specifically Unit Head Dr. Sudeep Kumar Ghosh, Shri Sachidanand Suwar, Head of Training IIPM, for all the support and making this program a reality. Just to give you a brief about the program, the 3-day certification program, which starts today, will have 2 parts to it. In the initial 75 minutes, we will have fundamentals of condition-based maintenance techniques get covered by the IIPM faculty, followed by a 15 minutes brief on how leading manufacturing companies have leveraged remote conditioning monitoring tools to drive plant and process reliability. So that's how we have structured it, so that we go beyond the theoretical aspects. We go also talk about how actually companies have leveraged new age technologies to implement CBM in their setup and thereby achieve profitable operations. So that's the context. On the very first day, that is today, we will talk about the basic maintenance philosophy, evolution of CBM, popular CBM techniques, and then we'll have a brief about the concepts about CBM. That's what we do. And second day, we will talk more about vibration monitoring and analysis for rotary equipments. Third day, which will be continued on, we'll continue our discussions around vibration analysis. We'll talk about infrared thermography. We'll talk about integration of CBM techniques with early detection of problems. So this will be a brief. Some of us may find it a little technical, but let me tell you, we all talk about smart factories. We all talk about connected setups, connected factories, Industry 4.0. But unless we have a context about these technologies on the shop floor, building a technology solution around it will not be possible, so to say. So it's very important, though you may find it a little hard in the initial period to grasp everything. But then even if you carry 30 to 40% of what is explained and taught through the 3 days, I'm sure it will give you a good concept and a good insight. And in fact, when you interact with your process team members and maintenance team members after this session, you would be in a far better shape to discuss and collaborate to build solutions together. So that's the premise for the program. I would now request Kamal Karnatak, President of CIOs of India, to say a few words about this program and also the way ahead. Over to you, Kamal.
Thank you, Atul. Good morning to all the learners who are here to learn something new on this beautiful Sunday morning. Welcome you all on this certification program on condition-based management to be conducted by IIPM. And as you all know that we, as a CIOs of India, which is a 24-year-old non-profit organization of technical professionals, we do conduct many learning program, but this program is a little different because it's a certification program. And many of you were part of our earlier certification program, which we conducted with IIT Delhi and IIT Mumbai. So similarly, we need to come to this program as a participant, as a learner. It is not like a typical webinar or virtual session which you would be attending in last 6-7 months. So come prepared with learning mindset. It will be a little tough. It will be a little technical, as Atul said, but we will start with the basics, and especially for manufacturing companies, manufacturing CIOs and head of operations who would be part of this program. It would be very interesting to know, and it would be very fundamental to know, because whenever you are implementing technical or IT solution, you need to understand the basic foundation of technical things. So as a CIOs of India, recently we have signed an MOU with NASSCOM COE, and as a part of our first project, we have partnered in Manufacturing Excellence Challenge. So Amit is there as a panelist, so he would also talk about our MOU. In the Manufacturing Excellence Challenge, where two companies have come forward to share their problem use cases with us, I would like to thank Annie Matthew of Mother Dairy and Ashish Desai of Grasim Chemical for coming forward for the same. So many startup companies in that manufacturing excellence program would be putting their heads to solve the problems as faced by these companies. So similarly, we are focusing on manufacturing organization because specifically in the realm of IoT, we need to have an understanding of basic shop floor. So that's why we have started this certification program on condition-based maintenance. If you go into the condition-based maintenance, it can be defined as a equipment maintenance performed based on certain indications which are there for the performance degradation. If you leave the shop floor part, the same thing can be true for your data center, same thing can be true for your own home, because wherever there are motors, wherever there are machines which are running, the same kind of condition-based maintenance can be applied. So welcome to all for this wonderful program, wonderful certification program, which we are starting today. And hope you would be learning a lot of things in these 3 days. Welcome you all. Thank you.
Thanks, Kamal, and thanks to the entire Executive Council of CIOs of India, especially Annie Matthew, for all the support she has been given to make sure that this program reaches to us to the stage where we are in today. I would now welcome Amit Saluja, Senior Director and Center Head NASSCOM Center of Excellence, Gandhinagar. Just to give you a brief, those who would not know Amit, Amit has more than 24 years of leadership experience in the field of business strategy and technology. In his earlier years, he has worked for companies like IBM, General Electric, and RPG Transmissions. I would sincerely thank Amit and his team for collaborating with CIOs of India and becoming a part of the Executive Council of the newly constituted CXOs of India, which we will talk about in days to come. Amit will request you to say a few words about the NASSCOM COE and the essence of condition-based maintenance, remote monitoring of assets in current times. Over to you, Amit.
Great. Thank you, Atul. And it's a great pleasure for NASSCOM COE to be joining hands with CIOs of India. And this is a great program or a great initiative which has been started by the CIOs of India. Definitely, the condition-based monitoring right now, it's kind of has become even more critical. I mean, it was always important earlier, but with the current kind of challenges that everyone is facing, it has even become more critical. And from the NASSCOM COE, we are kind of excited to be part of this. NASSCOM COE is basically an initiative from the Ministry of IT and the state governments and the whole objective is to drive the adoption of the digital technologies in the various sectors. The two key sectors that we have picked up for us is one is the healthcare and the second is the manufacturing. And manufacturing becomes a huge focus for us. We are running several initiatives to create awareness on what are the different ways that digital can be adopted for the different manufacturing use cases, and also kind of helping companies who would want to move forward on the digital journey. So any kind of support which is needed by any company while they're planning for the digital journeys, that's where the NASSCOM COE can definitely support, as this is the whole initiative from the government side. So the idea is to kind of more and more help to the companies and then drive the adoption of Industry 4.0. Now, I mean, that's partnering with the CIOs of India was part of this effort only. I mean, and it's great to kind of see there's a big community which is there and working for so long. There is a lot of interactions happening between this community. So I kind of am more than happy to kind of welcome all the CIOs here. And if anywhere you feel that NASSCOM COE can help in your digital journey, please do reach out to us. And again, thankful to the IIPM also for kind of joining us in kind of doing this program. As I said, I mean, this is very important right now with the whole cyber physical system that are happening now. There is a man and machine that they all are communicating. And this is the way condition-based monitoring is a perfect example of showing how the communication between the human and the machine can help us in preventing any kind of an failure and saving cost which can happen due to the breakdown of the product. So any kind of an early detection on any kind of a failure will be of a great value. And these kind of systems also helps us in some way saving the power of it, I mean energy. So this is a good kind of an system to reduce the cost. I'm sure, I think that we have a lot of experts here, but definitely looking forward to learning more about the in details about what are some of the nuances of there while in the condition monitoring.
I think thanks, Amit, and great. You very well articulated the essence of condition-based maintenance. It's important not just for maintenance aspect, but also from the energy saving aspects. And we keep talking about these topics, but it's very important to get deep down and understand the nuances, as you well said. I think without taking further time, what I would say, let me just quickly introduce to the faculty members who would guide us to the session here on. Uh, we have engineer Mr. Barik, Rajendra Barik ji, who is the senior faculty IIPM. He has around 27 years of experience in industry and technical training in the field of operations and maintenance. And he has worked in projects of HPCL, NTPC, and many more. And as a faculty trainer, he has provided best quality training in the field of condition monitoring techniques and on electrical engineering aspects and industrial safety as well. And not just to Indian participants, but to international participants as well. Joining him in this session, we have engineer Vishwajit Mohanta, who is the faculty and head of vibration department IIPM. He has more than 12 years of experience in the industry and also in consulting practice. He specializes in the mechanical maintenance aspects, CBM, and training around these topics. And what I would like to share before we immediately start the session is that this would topic is, as Amit also mentioned, Kamal also mentioned, is of extreme relevance for professionals in manufacturing and allied domains, either in operations, IT, OT, maintenance, or in quality assurance. There may be few slides or points which you may find it a little difficult to understand and it may not get cleared in the first instance. But as we then relate these points with the practical use cases towards the end of the day's session, in the last 15 minutes, it will get registered. For today's session, we have Adani Wilmer, who would talk about the implementation they have done on their shop floor to derive to implement these solutions and derive value out of it. Over to you, Engineer Parikji, if you can take us through the presentation now. Thank you so much.
Thank you, all panelists present the CIO of India. Good morning, everybody.
Yeah.
So, on behalf of IIPM, I would like to extend my thanks to all the panelists present in CIO of India. So, without wasting time, so we should start our session. So, I think all participants are present. So, now we will continue our session. Okay, thank you. Just okay. Is it visible, sir?
Yes, it is. Yes, it is. Please go on.
Okay. Good morning once again. My dear technocrat leaders present for the today's condition-based maintenance sessions. Sri R.K. Barik, on behalf of Indian Institute of Production Management, once again welcoming to our condition-based maintenance world. So before entering into the condition-based maintenance, so as a professional, industrial professional or engineers, as a technocrats, what we are doing in day-to-day life. So we are facing a lot of problems, just like doctors. Those are working in operation and maintenance as well as production department. So production is very, very important. Nowadays, production department is hankering for the production. So it is two hands, one is operation and maintenance. So there are so many production inputs manufacturing industries and companies are utilizing. So just like land, main machine material and methodology. So machine plays the vital role. Just a minute. No need to discuss more things about me. So time to time we will interact each other, and already start given my brief introduction about myself. So anyway, so what should we know? Every organization has a production center, cost center, and profit center. How can we make it? If everything is fit and smooth and fine, then it is possible to make our organization, production center, cost center, and profit center. At first, we should develop ourselves, and then we will be able to develop our organization. To make the organization, production center, cost center, profit center, what should we know? Know your organization first. What is its mission, vision, goal, target, and policy? And product, production, productivity, process, and control. And what are the resource and facility available in the organization, like land, capital, man, machine, material, method, market, cost, time, quality, quantity, skill, leadership, motivation, training, standardization, standards, rating, specifications, design, procurement of the machines. Besides that, transportation systems, installation, testing, commissioning, training, monitoring, analysis, and what are the losses, what are the wastes, very, very important, safety and hazard in the organization, house coping, 5S, overtime, allocation of the machine and material and human resource, energy conservation techniques, environment impact assessment, of standard operating practices, standard maintenance practices, and tools tackles, and overall effectiveness of the machine, and whatever the maintenance policy why we want to adopt our organization, that should have overall effectiveness of the equipment as well as return on investment, because our senior management always ask return, whatever the plan and whatever the project we are showing them, they are initially asked what is the return on investment. So for this, we have to convince them, so whatever the return, then importance of the workplace safety, very, very important, safety first. Otherwise, if we cannot create a zero accident prone, zero breakdown prone in our organization, so cost will be more, measurement techniques, protection and control, prevent assessment and hazard accident, health and safety programs should be time to time given. So before entering into the condition-based maintenance world, since we are doctors, why machine fails or why human beings suffers? There are so many reasons. Machine and man and machines are analogous to each other. Machine has a life, we can extend its life. So what are the reasons? What are the reasons machine fails in the organization? So in this web sessions, web training program sessions, so interaction is nowadays now not possible. So anyway, I'm telling to you. So first, manufacturer factory or manufacturer manufacture the machines, then it comes to the organization or industry for the productivity sake. First, so whatever the capability or withstanding capability, building capability, that should have a machine. So design general in the manufacturing industry, the machines are designed in the various processes. due to poor quality of raw material first. Whatever the component of the machine is designed, if poor quality of raw material is there, the machine fails. Second is poor workmanship. Those are designers, those are working there and designing the component of the machine and assembling them. If their knowledge and skill is very poor, then lot of problem is there. Third thing is due to transportation problems, and also in the after installation, commissioning, erection, what happened when machine start their life, begins the production. At that time, what happened? Various due to environment, due to hazardous and non-hazardous area, the allocation of the machine suffer various type of stresses. That stress creates a lot of problem in the machine. Besides that, whatever the crews or maintenance crews, operational crews working in the industry, if they have lack of knowledge and lack of knowledge in maintenance and operation, then machine fails. So human being and machines are analogous to each other. Human born for die. Mr. Burma has designed the human beings. So after a stipulated period, maximum 100 years, you will die. But a doctor cannot extend the life of the human being. Already it is stated. But machine never dies. Since we are user, we always speak, machine never dies. It killed by the human. It killed by the environmental attack. It killed by the stresses. It is killed by the lack of handling. But it made for sick. Just like human beings, due to changing of operational conditions, due to parametric change, the machine become sick. But here we can extend the life. Residual life assessment is possible. We can extend the life. We can measure the life, how long the machine with us. Like human being, machine has 3 lives: strategic life, as usual life, installed. Then after 30 years, 40 years, it will shift it. Technical life, all the technocrats are well in sound knowledge and skill, expertise is there. Then technical life enhance them. Economical life, if we time to time, if we invest the capital and bring the new technology to save the life of the machine, so it is very fine, economical life extension. So we can extend the life of the machine instead of, so now nowadays there is a challenge between the user and manufacturers. We the user, we can challenge to manufacture. You give a 20 years, 30 years machine, we can extend its life double years, triple years. So equipment life cycle depends upon the specifications, design, manufacturer, quality, transportation systems, shipping by train or truck or aeroplane, erection, commissioning, layout is very, very important, operational, maintenance, and protection control systems. And so whatever the machinery basket in your organization, whatever electrical, mechanical, instrumentation, electronics, whatever they are, so which area you may work, maybe operation, maybe production, maybe instrumentation, maybe maintenance. At first, whatever the machine we are using for our productivity to enhance their life, reduce the cost, make the organization, production center, cost center, profit center. As a technocrat, we should know basic and fundamental of the equipment as well as equipment system. That means theory, principle, working principle, operational principle, symbol, formula, everything. Then second point is constructional and design features. Constructional and design feature is very, very important. So whatever the component present in a machine, what's its design feature? That is, what is its function of the component, we should know. Then which material it is made up of, we should know. Then third is, what is the disease or why it is suffers, why the trouble comes. So we should know this. functions, parts material, and also parts disease we should know, construction and design features, just like a doctor. The next is rating, specification and standard of the machines, troubleshooting guidelines of the machine. So if troubles comes, how can technocrat shoot the troubles immediately at a glance? That technology should we have. Then standard operating procedure of no doubt operation that does not mean stopping and starting. Operation is just like a cart. Operation is just like a art. We can know the starting, stopping, accelerating, regulating, protecting, controlling, programming, setting, resetting. Everything is coming under the SOP is there. Either you follow the manufacturer guidelines or otherwise whatever the SOP prepare each for each and every machine you should adopt. Similarly, standard maintenance procedures, manufacturer guidelines, or as per your environmental conditions, you prepare the standard maintenance practices for the each and every machine. Particularly, we have different kind of machines, particular types of machine, maybe motor, maybe transformer, maybe pump family, maybe whatever the machinery. Standard maintenance procedures should be there, time based or condition based. So at first, what should we will do? We will have to segregate the each and every type of machinery. Normal machines, standard machine, normal, marginal, critical, catastrophical machine, heavy duty machine, as per their ratings, as per the environment condition, as per their duty, as per their working load, we have to segregate the machines. Which machine we should give more importance? Accordingly, standard maintenance practices should be prepared by you or your organizational or departmental head or maintenance engineers. Standard overhauling maintenance procedures. So that should be a time frame work after 3 years, 7 years, maybe within 1 month. But policy should be there. Skill enhancement, time to time, operator and maintenance personnel should be taken training, and they should be acquainted with the intelligent management systems and CMMS procedures, computerized maintenance management system softwares, and the IoT sensors. They are IoT sensors. So in the last session, CIOs of India will give the introduction of how the IoT is working and everything. We including the condition monitoring sessions. Then we should know the overall effectiveness of the efficiency. When we are talking about the overall efficiency of the equipment, means we should know the performance of the machines, availability of the machines, and quality of the machines. Energy conservation techniques. So everybody is saying our organization get the more profit this year, will get the more ex gratia, incentives, everything. But whatever the input energy we are consumed for the productivity, so if you measure the energy, there is a huge energy loss. Process safety, energy, environment auditment should be there. What is their procedure? What are the records? What are the data kept for the audit? And at the time of audit, the team or our head will be present and give the reports, preparation of maintenance strategy for the whole organization. It depends upon your ratings, spacings, and environment condition, location of the machine, system of the machine. Then we should acquainted with the list of the tools, tackles, testing kits, sensors, diagnostic tools, analyzers, softwares, various softwares, and various technology. Then we can handle all these things. Study of drawing, like single line diagram in electrical engineering, control diagram in the hydraulic systems and motors, list of technical experts. So whatever the human resource we get, there are 4 kinds. One is your unskilled, semi-skilled, skilled, highly skilled, and experts. That will be categorized in a team. Unskilled will be skilled, semi-skilled will be unskilled, skilled will be highly skilled and expertise. And spare part maintenance parts, list of spare part we should know. In the time of maintenance, which part is required, which part will be replaceable, which part will be, that will be a material handling is a very, very important. And material purchase, there is a procurement department in every organization. Material purchase, because before purchasing a machine or material, we have to prepare the indent letters, and we should know about the machines and quality of the material. And at last, whatever the work you are doing, everything is valueless if you are not keeping the record hard or soft. So anyway, in the troubleshooting guiding, so whatever the when the troubles happen in a machine, so at that time we should know the symptoms. Means lachan क्या हो रहा है, गर्मी हो रहा है, sound आ रहा है, that should be the symptoms. We should judge the symptoms, or the whatever the sensor is present, that should capture the or feel the sound, noise, your heat, cold, increase of parameters, that means symptom लक्षण. जैसे हमारा like when humans are suffers, oh means trembling, that just we are telling malaria or viral fevers, dengue fevers, that type of symptoms. The operator and maintenance people should know this causes and reasons why it happen, why this symptom is occurring. So what is the, then name the types of disease or troubles happening in the machine. Then you try for remedies, preventive and corrective measures by the suitable maintenance technique. So we are the troubleshooters there. We should know the troubles and then shoot the troubles like a military person. Troubles means problem in the machine, disease in the machine, fault, failure during the abnormal, critical and catastrophic period. And shooting means we should eliminate, eradicate and abolish the problem in the machine occurring by technical shooters. Those are experts. Then in the machine, like human body, there are two types of troubles or problems. One is sporadic troubles or minor troubles. Problems come and go. Immediately, just you tighten the nut bolt, problem. If you reset the value, that problem comes and go. Chronic troubles means increase in multiple ways. Cause, effect, effect, cause. Cause, effect of cause, then effect become the cause become the effect simultaneously, and one part to another part, then that is chronic troubles. Sporadic troubles, root cause finding is very not it is a easy task, but chronic troubles are there where exact the root to finding this. So we have three tools. One is root cause analysis in general ways, whatever the fault, whatever the failures, whatever the reason that you know time to time doing. Then second is why analysis, or put yourself interrogative signs. What, why, who done this, why it is happening, which place it is happening, what are the parts. Then here you can always you ask why, 3 why or 5 why, finally you will find out that. Sometimes why analysis not also give the result correctly. So then we go for phenomenon mechanical analysis. That means we should know the product input like material problem, maybe human problem, maybe component problems, maybe methodology problems, operating criteria. So that we are using. Besides that, the very important things, just I would like to share to you, there are several stresses in the hazardous area as well as non-hazardous area acting on the machine. Electrical stress. Electrical stress means over voltage, over and under all the electrical quantities and parameters. Voltage, current, power, resistance, impedance. If it is in balance, that is electrical stress happens. Magnetic stress. Magnetic stress means overflux and underflux. Insulation and dielectric stress. Insulation and dielectric stress means that is insulation deterioration, insulated due to moisture attack, humidity, oil deposition. So there are so many reasons for the insulation deterioration. Mechanical stress, you know, misalignment, mismounting, miscoupling. These are mechanical stress. Thermal stress means temperature, overheat or underheat. Vibrational stress, just like to and fro motion of the up and down or back to front force. That's like oscillations. Just like a spring, vibration stress. Load stress, overstress and overload and underload. Dynamic stress means when machine is rotating, that means crawling, cogging. These are the dynamic stress. In a motor, if you in a motor component, these are the stresses normally equated. That means before finding the stresses and failure, we should find the fault zone. In the condition-based maintenance techniques, fault zone is very important. Just like a doctor, you have to categorize you keep some component in a particular zone, that is called fault zone. In the motor, I have taken 4 zones. It may be even also cooling is a zone, external zones and internal zones. So stator winding, rotor winding, we are just overlook this. Tick mark is, that means this type of stress is occurring. Okay, next. So now the maintenance. We are shouting maintenance, we are doing maintenance. So what is maintenance? Maintenance is just nothing but a function in the manufacturing function. So we have to keep the equipment in the healthy condition to obtain the operational, functional characteristics. The main objective of the maintenance is to minimize the breakdown or downtime and keep the plant and machinery system in the working condition. Machine and other facilities should be kept in such a condition to permit them use their optimum or capacity without interruption or hindrance. Then production should not be stopped. We should ready operation and maintenance department should able the machine or ready the machine for the productivity, and we should ensure the production department and operation department take this machine and run for 3 months without any break or without any stoppage. So very few definitions for your present. Keep the health of the equipment or the machine in the health condition to achieve operational or functional characteristics by suitable care, activity technique called maintenance. So whatever the activities means whatever the activities we are taking. The combination of all technical activities, visual inspection rules, and also your servicing and repairing rules. Administrative activities means administrative control. Managerial activity, how can we prepare the maintenance and operational strategy and apply in the image, including supervision actions intended to retain an equipment. That means keep the equipment healthy and it will continue and we can achieve a smart operation. And formal definition of maintenance is that function of manufacturing management that concerned with day-to-day problem of keeping the physical in a good operating condition. That means machine should not be break. So next, why do we need maintenance? What are the cost of doing maintenance? What are the cost of doing not maintenance? What are the benefit of the maintenance? How can we maintenance increase? So maintenance, why maintenance? Maintenance to improve or enhance the performance, life of the equipment, and achieving the reliability, availability, and maintenance. Very, very important. If your machine or equipment is maintainable, then it is available for the periods. Then if it is available, then machine is reliable. If your machine is reliable, your quality is well and good, then you can ensure the operation department as well as production department, sir, take this machine and run it for 3 hours, 3 months or 6 months without any stop. Then beside that, we are doing maintenance, save the time, energy and money. And to eliminate the breakdown means decreasing the downtime and increasing the uptime. This is the very, very important thing. And besides that, we are saving time, money, and energy. So when we are talking about the maintenance concept, maintenance having some letters. Maintenance is a word and activity, and in this word, some letters are there. Every letter has a meaning. M stands for machine. A stands for always. I stand for in. N stands for new, T stands for top class, E was efficient, N means neat, A means end, nice, condition, and everywhere. Every letter has a meaning. That means in our organizational or industrial periphery, we will ready the machine. What should be there? Machine should be always in new, top class, efficient, neat and nice condition everywhere. That means smooth operation. So India as well as abroad in the whole world, and world-class maintenance strategy allow to use some maintenance technology So breakdown maintenance that you are doing. Breakdown means immediately it is on-plant maintenance. Preventive and time-based maintenance. Preventive and time-based maintenance means and predictive and condition-based maintenance, corrective maintenance, reliability center maintenance, total production maintenance. If we CBM plus, if you connect all the CBM sensor in a IoT sensors to a CMMS, computer maintenance management system, and automatically it will sense the all kinds of fault, and finally we will achieve the glance report about the machine condition, health condition of the machine. So anyway, the breakdown maintenance, preventive means whatever the maintenance technology we are using for to prevent from the breakdown, that is coming under the preventive. Under preventive maintenance, time-based maintenance, predictive maintenance, and condition-based maintenance and predictive maintenance, also preventive maintenance. Time-based maintenance also, so whatever the periodically, hourly maintenance, daily maintenance, weekly maintenance, fortnightly maintenance, monthly maintenance, semi-annually maintenance, annually maintenance, after 2-3 year maintenance, all are coming under the time-based maintenance. The condition-based maintenance, whatever the condition, so keeping the to know the health condition of the machine in an early and well advanced state using some technology like diagnostic tools or analyzers or sensors. That technology known as condition-based maintenance, and monitoring the parameters and measuring it and controlling it, and we can predict the failure and troubles from the machine, that is predictive and condition-based maintenance. And after knowing this, we are whatever the maintenance, the corrective maintenance. Besides that, if time-based maintenance and condition-based maintenance is sum up, including root cause analysis and fault finding analysis, that become the reliability center maintenance. And total production maintenance means
Barik sir, we are unable to hear you, it seems. Kamal, are you able to hear him?
No sound is coming.
Okay. So I would request Bishwajit ji, if you can just check and maybe you can take us through till the time he joins in. Bishwajit ji, you can unmute yourself.
hello sir, any problem?
No, actually we were unable to hear you in the last minute or so.
Or last minute?
Yeah.
Okay,
So maybe you can continue.
Yeah, and your screen is also not shared, so you can again start sharing your screen.
You can share the screen again, please.
Okay, just a minute, sir. Stop sharing. Where is that? Share screen is there. Okay.
Are you able to share the screen?
Just a minute, sir. So now it's coming, sir. Major types of maintenance. Is it coming, sir?
No, it's still not visible.
No, it's not visible. आप एक बार screen share करो आप एक बार दोबारा.
Okay. I'm doing that. So now it's coming, sir. Hello.
Now it's coming. Go to the presentation.
Okay. Now okay. It is in the splitted form.
Yeah.
Please go on. You can now
Just
select that. You can
okay,
select that
okay,
particular
okay,
screen
okay.
and yeah, go on.
Okay, sir, I'm doing that. I'm that doing. I'm that.
Perfect.
Okay.
Okay, no issue. Okay. So now screen is available, sir.
Yes,
So
it
you are
is.
ready, reference?
Yes, it is.
Yes,
Yes, it is.
yes.
Go on.
Now it is perfect. Yeah. Go on.
So maintenance can be classified in various ways: planned maintenance and unplanned maintenance. Unplanned maintenance means your breakdown, and emergency maintenance means shutdown maintenance at the time of requirement. If a machine or system stop, at that time, whatever the maintenance taken out, that is called unplanned maintenance. Planned maintenance by the plant maintenance managers, they are doing preventive, predictive. Preventive means time based, and predictive condition based. And for the after knowing the consequence, whatever the maintenance we are doing: improvement maintenance, corrective maintenance, statistical, further predictive maintenance, statistical based, and conditional based. Periodically we are doing, and condition based means seeing the condition. And improving means engineering service or any design we have to change. Now old machines are some changing in the designs, we can do this. Corrective maintenance, and these are the maintenance. I think we should not give more time in the maintenance strategy. It will take my maintenance engineering management takes 1 month. Anyway, so normally what we have maintenance strategy prepared in the organization: mainly replacement, repairing, overhauling, preventing maintenance, design modification if required, breakdown correction, fault finding, and opportunity maintenance means time to time. And in the preventive maintenance, condition based and strategical based. Condition based means offline and online. Offline means without another means de-energized state and machine when stopped. Online means when machine is running or even also energized condition, we can take this. And statistically reliability means time based and use based. So maintenance approach mainly preventive maintenance and predictive maintenance. You forget about RCM and TPM for this stage. So after that, you will able to know the reliable center maintenance after acquainted with the condition-based maintenance and condition mounting tools and technology. That will be fine. So what is the objective? What is the goal? To perform the maintenance just in time before the equipment fails in service. So whatever the time-based maintenance you are doing in your for your organization for the machine sake. So I am giving you the 2 rules. You should follow these during the operation and maintenance. Definitely 50 to 60% breakdown will be, instead of 10 breakdown in a year, you will get 3 or the 3-4 breakdowns. First is every operator and maintenance people during the maintenance period and of a visual inspection is very well. LLFST rule: look, listen, feel, smell, touch. Touch by tester. Nowadays, touch by tester is not advisable. By putting a gloves or by any other things, you can touch it. This is very important, just like our 5 sense. Then during the repair and service rules, whatever the maintenance activity normally we are doing: drying, cleaning, cooling, tightening, lubricating, resetting, adjusting, sealing, painting, that activity during general maintenance and overhauling maintenance, that you should acquainted with this. You time to time, as per the requirement, as per that is called need based maintenance, you do it. Definitely 50 to 60% breakdown will be overcome. So what is the maintenance objective? Why we are doing? What is the main objective of the maintenance? Is maximizing and minimizing. Production will be maximized. Equipment efficiency, performance, and overall effectiveness of the equipment will be more. Improving the inventory controls means spare part management will be controlled. Optimizing the resource utilization, more energy, more material instead of this, and optimize the useful life of the durability, longevity will achieve, and budgetary maintenance, budgetary control will be achieved. And what we will downsizing this: minimizing the breakdown, minimizing the downtime, uptime will be increased, energy will be decreased, and implementation of cost. Finally, cost reduction seed. So I don't know in your organization how much percentage of maintenance cost you are keeping in terms of production cost, keeping for your maintenance. But every organization, there is a rule. Nearly doing TBM, time-based maintenance, we are unnecessarily investing the 35% of the production cost in the maintenance. Maintenance is just a will, it plays a demon days in the organization. So we should, nowadays, people are thinking the prevention of the maintenance. Prevention of the maintenance. So you see the use and throw batteries are coming. Maintenance-free batteries, maintenance motors, Japan and other countries, they are using maintenance-free motors. Means up to 5 years, they installed without any problem, without any jerk. It will continue 5 years, then you shift it, again replace the new motors. That strategy they are using, that is smart replacement strategy they are using. So anyway, so that things maintenance benefit, availability, reliability, maintainability. This is very, very important. Performance, overall effectiveness, that is important. And longer service instead of your economic service and life cycle, also more. Prevent breakdown means downtime will be less. And optimizing the inventory, minimum cost, smooth operation, and also for the sake of the maintenance, people should be trained. So in breakdown maintenance, people said the early 1950 to 2000, people are in India, they are doing breakdown maintenance. At that time, experts are not available. We are dependent upon the foreign countries. Those are manufactured. They will take after 3 months, 1 month. At that time, postal card, we are sending all these things. So now internet, IT technology was not there, and digital technology is not there. But now what I am doing, and you are far from away listening to me. But at that time, so preventive maintenance, preventive means the maintenance technique what we are using to prevent the breakdown or downtime, that is called preventive maintenance. Under preventive maintenance, that is time-based maintenance, means periodically what we are doing throughout the year, hourly, daily, already I have told you. And predictive maintenance means we can predict the failure, we can predict the health condition of a machine in early stage, in the well advanced stage, we can determine the fault and failure. And using some technology, or we can say diagnostic tools, or analyzer, or measuring meter, including sensor and software. Without software also, we are using so many condition monitoring tools. So in preventive maintenance or time maintenance, what you are doing day-to-day life, just overlook this, I think. Then offline condition, we are doing bearing replacement, overhauling, that we know. Overhauling maintenance is not like your general maintenance. In overall maintenance, everything will be total machine will be de-energized, it will be stopped, then permission to work will be taken. Before that, de-energize the machine, earthing the cables and wire, whatever, if it is electrical machine, then segregate all the components, disassemble the machines, then you apply the visual inspection rule, and as well as your repair and service rules. So for then again assembly it, go for start and manually, and energizing, you go for test run, then site clearance, and knitting and cleaning, keep the periphery of the machine neat and clean, and whatever the activity you do, finally we are doing rectification. So for overhauling maintenance, the when, who, where, and for which machine the overall will be carried on. That is, for this planning we have to do scheduling, coordination, job procedure, safety precautions, SOS, or preparation. So what about the equipment, what about the tools, what about the kits, what about the measuring instrument, that we have to name. Job startup, job completion, test run, clearation, housekeeping, that we are doing. So without wasting the much time in the maintenance, we move forward to the predictive maintenance and condition-based maintenance. So already I told you the maintenance, it is a maintenance techniques or technology we are using to predict the failures of each and every component of a machine in early stage, in well advanced stage, using some condition monitoring tools or diagnostic tools, or you can say measuring meters, including sensor and softwares. So that type of maintenance is a condition. Seeing the health condition of a machine or component, whatever the activity we are doing or proactive, whenever we are showing or corrective action we are taking, that is called predictive maintenance. After that means suppose a bearing is going to fail, just we know by using the condition monitoring tools like your thermography camera or the loop oil analysis, immediately you take corrective action, and so bearing replacement is not required. So that bearing will continue another, instead of 15 days life, it will continue 1.5 years. So normally, just like your medical science, it comes into era from the medical science. Our engineers, valuable engineers, prominent engineers of the different countries like Switzerland and Japan, and also they started designing the instrument like condition monitoring tools or analyzers, sensor and software technology. The condition monitoring tools combination of three technology: instrumentation, electronics, information technologies, and your information technology, electrical, electronic engineering, instrumentation, and information tech. Combining these, the equipments or instruments comes out into era that will detect the failure in the early stage. Your vibration, thermography, motor current signature analyzer, and also loop well analysis, dissolved gas analyzer. So many condition monitoring tools nowadays available. So main objective is to prevent the tripping or prevent the equipment failure. Offline mode and online mode, you can use it. So early, we can predict early warning of failure, performance only when it is necessary, lower maintenance cost, less downtime, higher availability, reliability, improve the overall effectiveness. These are the benefit we can get. So this is the definition, the maintenance technique method by which health condition of each and every component of a machine or machine system can be predicted or determined or judge the troubles, failures, problem, defects, fault in early or well advanced stage using the monitoring diagnostic tools, analyzer with software, and connected with the sensor for monitoring the various parameter of performance, that is called predictive maintenance. Under also we can say condition based maintenance technique that help determine the condition in service equipment in order to predict when the maintenance should be performed. The primary goal of the minimize the disruption, normal system operation, and without decreasing the downtime, increasing the downtime, increasing the uptime. So plant maintenance, the maintenance is performed based on the predefined schedule of interval, that is time-based maintenance, and maintenance is performed based on the asset of the health indicator, that is condition monitoring, condition-based monitoring.
Barik sir, I'm sorry, I'm interrupting you.
Yeah.
So you spoke about this OEE, overall equipment effectiveness. We keep hearing this.
Okay. Sir, so this question is to me. Now you want from me? Okay. Overall
Maybe
effectiveness.
You can just touch upon it.
Let me finish.
Yeah.
Efficiency and effectiveness are not same in the sake of productivity. Effectiveness is the degree of measurement of the performance or efficiency of a machine. For calculation of the overall effective of the machine, when machine to judge the reliability and quality, we are finding three parameters, other parameters: performance, efficiency, and also availability and quality. If you multiply all these things, PAQ, overall effectiveness, PAQ, performance, it depends upon the performance, availability, and quality. Performance multiply into availability into quality, then you will find out the overall effectiveness. If overall effectiveness of the equipment is well and good, then machine is reliable, available, maintainable, available, and reliable, and ready to perform his particular functional characteristic for this sake of production. Okay, sir. For this time, this is the
Yeah, yeah,
answer.
yeah,
The
yeah, yeah,
calculation
yeah.
is more and more.
Perfect,
Okay.
perfect, perfect,
Okay.
perfect. Go on.
Okay,
Thank
sir.
you.
Okay. Welcome, sir. Then uh, uh, before entering into the condition monitoring world, so there are so many stages. If we take the graph, that is graph is called PF graph. P stands for potential failure, F stands for functional failure. So in the life of a machine, period to period, if we draw a graph, time in a year, and in the y-axis, if we take the failures, so initially when machine is installed, it's a good condition in the high position. The warranty period covers 5 years or 10 years. It runs smoothly, it's normal maintenance, whatever we are doing, tightening, loosening, whatever resetting, painting, drying, and hardware, software problems. So what that we are managing, warranty period is over. After warranty period, so 3 to 5 years, then we will prepare a maintenance strategy for the preventive maintenance, that is called time-based maintenance or periodic-based maintenance, daily, hourly, quarterly. So then another some years and another year, this is the time-based maintenance phase. Then machine will run. A particular time will come due to smart operation and smart maintenance strategy using. Then still there is breakdown. A point come, the potential failure starts. Properly we have taken care, we have not taken care about it, then potential failure starts. So gradually that we are trying to implement the CBM technology here. If you want the building capacity, the constant mechanical, electrical, and other technological constant kept in the by the designer due to residual stress, potential failure starts. So from that day, you start and judge the trend analysis, and you do plain condition based maintenance, your condition monitoring start, monitoring, measure, and control, and take the preventive action. So finally, after some year, 30 years, for 20 years, after 20 years, 30 years, another point that then machine starts degrading. All the components loss is constant, whatever the kept by the constant kept by the designer. So it loses its inbuilt capacity, and finally functional failure occurs. So this P to F is called PF curve. During this period, the condition-based maintenance we are using, and somewhat we reduce the maintenance cost as well as maintenance cost, as well as we got some profit, and we are trying to save somehow, try to save the machine. Then after functional failure, then question arises after functional failure. Then we should take utmost care so that we can extend the year. You will decide for how many years the life of the equipment remain, and how can we extend the life for more. So you start here automation or reliability center maintenance with that means at a glance, and here it will become a critical machine. It means catastrophic condition arises, inbuilt capacity going to decrease. तो then मतलब एक मुर्दा लाश को कैसे हम जिंदा रखेंगे for the 20 years, 30 years. So that will be the work. That's why in the condition based maintenance process, technology requirement means tools, tackle, instrumentations required, software and sensor require, people skills. That means some people should train to handle the technology, condition based technology, and communication to integrate the available equipment condition data. Data should be captured, trained analysis, diagnosis, comparison of the data after means October month, September month data, and October month data, or 3 month data, or 6 month data. That will be compare, interpreted, then analysis, then maintain a history of the operator logs and history logs, and design the data, then data acquisition system is required. If IoT sensor is used, then it will be required. Otherwise, trend monitoring. So what we are measuring, actually various process of parameter like pressure, temperature, means mechanical quantity, electrical quantity, thermal quantity. So whatever the parameters used in a machine, that we can measure and control, and seeing the parameter, normal value, standard value, marginal value, and critical value. Then we will in the trend, we will mark the three colors, blue or green, yellow and red. Then doing the trend analysis, you can assess the equipment health condition. In the principle, that is trending monitoring and condition checking. Condition checking, just knowing the conditions, whatever the parameter value is coming, whether its health condition is the component condition well or good, that we are deciding. Trend monitoring means totally just diagnostic, means period to period. So what is the condition? Condition at a glance. You are sitting in the classroom, in the conveyor belt, a motor is there. So what is its condition? What is its health condition? What is its starter condition, component condition? Each and everything in your dashboard. See, in machine, normal life is, that means from the installation period to early failures, no problem. Then taking the CBM's useful life, this is bar tube curve, a random failure, then wear failure, the year functional failure starts, and finally we have to utmost care. So 14 CBM assessment, 14 CBM assessment areas are very, very important. Uh, One is preventive maintenance tax technical basis, the technology application, which technology will apply, process flow definition, program leadership, and organization role and responsibility. Who will take the responsibility? Whose role is what? Information management, IMS and communication system, equipment condition assessment and decision making, training and qualification, CBM work prioritization and scheduling, work closeout and maintenance feedback. These are the factors for the CBM assessment, and goals and performance metric, calculation of cost benefit and return on investment. This is very, very important, because your senior management is eagerly watching what is the return on investment. Suppose they are asking, you are going to implement the IoT sensor and condition monitoring equipments. It's very costly, capital cost is very high, 5 crores or 3 crores or 50 lakhs you want to invest. But what is the return on investment? At that time, you have to convince your senior management, sir, these are the benefit we will achieve the asset ownership after 3 years or 5 years. So in our, suppose in your organization, maintenance, time-based maintenance, by doing time-based maintenance, 35 rupees or 35% of the production cost is invested in normal maintenance or overhauling. By doing condition-based maintenance or predictive maintenance, if you reduce the maintenance cost, first year 5%, second year 10%, like in after 5 years, 35% become decrease, finally it become 10%. That means lot of money we earn from the saving, the maintenance cost is saved. So that then you will get the asset owner. Suppose you have purchased a vibration analyzer with software, thermography camera, thermocam. So that return on investment indirectly 3 to 5 years. And you have to see the depreciation cost. You have to take into account the depreciation cost of the machine as well as everything. Customer satisfaction, then product will not stop, and well quality, good quality of product, no defect, continuous improvement. And normally, there are so many condition-based monitoring tools are so far discussed, and popularly we are using vibration analysis, oil analysis, lube oil analysis, and wear debris analysis, thermography, and for the noise and sound, ultrasound system. Besides that, in India, in Indian industry, 20 to 30% they are using predictive maintenance. Rest same time-based maintenance. In the world, 30 to 40%. But so where can predictive maintenance, where the condition monitoring tools, sensors and reliability, CMMS will be installed? That is a question mark. That you have to discern the condition, financial condition, technical condition, expertise of the organization, that keeping into account, that should be decided. It totally depends upon the management, as well as the number of machine family, how many pump families are there, motor families are, transformers are there, compressors are there. The number of, seeing the number of equipment that you have to, and how many are old machines, what are the new machines, so how many already sharp for 10 years, 20 years, that will be categorized, and decision will be taken by the management whether we will implement CBM or we will prepare a roadmap for this. The various condition monitoring tools nowadays, it is available: visual monitoring, vibration monitoring, temperature monitoring, lubricant monitoring, leak detector. For every monitoring, there is a condition monitoring tools, or we can say diagnostic tools, or analyzer is used for analysis, including software, and without software, it is also available. World popular condition monitoring technique used for CBM are this: vibration analysis, infrared thermography, oil analysis, or you can say tribology, oil analysis, and wear debris analysis. Beside that, I am in this page. I will take 5 minutes. See, we are using a machine. We are using industrial in the machine, in the industrial basket, electrical, mechanical, electronics, instrumentation, whatever the machine and equipment and system you are using, that does not matter. But thermography, hotspot analysis, we can find the failure also. For the motor sake, we are using MCA, motor circuit analyzer. Now it is ECA. Now it become ECA, electrical circuit analyzer. Initially it was MCA. MCSA, motor current signature analyzer. Empath technology you can use. Electrical motor performance and trained hardware. Partial discharge monitoring. In the motor case also we can use thermography techniques, and also vibration we can use. Lube oil analysis also, motor testing, motor monitoring, health monitoring we can use. For similarly in the transformer oil monitoring, we are using breakdown voltage, diesel gas analyzer, furan analysis, degree of polymerization for insulation monitoring, moisture analysis, even also thermography we can use also, transformer thermography, and also partial discharge PD monitor, noise analysis, ultrasonic we can use also. Battery testing for voltage and your specific gravity instruments are available for the battery testing. Ultrasonic noise analysis, vibration analysis for vibration, lube oil analysis, that is tribology. Tribo means friction, logy means science, to deduce the frictional science, that is lube oil analysis, physical properties, chemical properties, and also wear debris or corrosion analysis. Then a machine condition index we are finding. Moisture analysis for lube oil analysis, transfer oil analysis, and also aseptic circuit breakers. We are using dew point analysis. We can know the condition of the sulfur hexafluoride gas. Besides that, insulation monitoring, insulation analysis in electrical equipment, 10 delta and capacitance test kits nowadays available. Insulation resistance instead of Megger, high voltage insulation tester is available. Polarized index, measuring this, taking this parameter, we can analyze the insulation analysis. Similarly, for magnetic monitoring, flux monitors are available, analyzer available, power analyzer. Power analyzer plays the vital role nowadays, including the thermodynamic in the electrical area. Harmonic analysis also there. If you purchase a power quality analyzer, the name is not power analyzer, power quality analyzer, it works 48 to 64 works. 48 parameters to 68 parameters. Easily you can take the all the electrical equipment healthy condition. Mechanical and chemical analysis. And nowadays circuit breaker, relay, and shock analyzer also available. The cost benefit. So when you implement the CBM, cost benefit, time benefit, we should have to take into account. Minimum equipment damage required means uptime, downtime will be less. Minimum oil use, display, less use of inventory item through the reliability enhancement. Indirect cost, less fast loading due to equipment outage. Time, downtime will be less, uptime will be more. Mean time to repair and mean time before failure. That difference also. Suppose during 3 months, one failure was happening. No, after 1 month or no, sorry, after 6 months or 9 months, it happening. That means this is the necessity. Whatever for the predictive maintenance sake or condition based maintenance sake, whatever the condition monitoring tools, diagnostic tools, analyzer with software and without software, including sensor technology, what we are using. So main benefit of the organization is first is asset protection. So asset is the property of the machine asset or equipment asset is the property of the organization like human resource. So first, machines are protected from the all sorts of problems, disease, failures. Second is maintenance cost will be decreased. Within 3 to 4 years, implementing the CBM, instead of 35%, it will reduce to 10%. You calculate or assess your what was your maintenance cost after implementing, what is the cost. Improving the uptime means downtime will less, time, money, and energy saved, increase profit, return on investment. I have already swearing you, if you implement the world 3 popular condition monitoring tools, 3 to 4, like you install a low well analysis center, that will be low, and also your vibration analysis analyzer. You purchase thermography camera as per the equipment system, as per the number of equipment, and if you have pipelines, and how many? Yes, sir. Anything, sir? Atulji?
No. I think we were just about. I think maybe we can conclude for the day in the next couple of minutes, and then we can continue on the second day, so that we
I
can.
am sort of, okay. Let me only. I think.
Sure.
Okay.
Go on, please. Please go on.
See, that means the cost benefit analysis is very important things, and implement of CBM, and means how can we prepare the roadmap on the last day, on last Sunday, means coming Sunday. I will take thermography as well as double DA, including the remaining portion of the condition based maintenance. Sir. Hello, sir. Is it okay,
Great.
sir?
Perfect.
So
I think. Go on, Barik sir. Go on.
Because due to time constraint, so many things I have left, just skipping all these things. Just I am summarizing and consolidating all things. Okay,
Please.
return on investment is very, very important. Everybody in our family budget, we are also expecting this. Similarly, our management is expecting from this, because the organization will invest money. Definitely, they will ask for for a return on investment. We the technocrat here, we have to foolproof it. We will show them, sir, you see, we have invested 3 crores or 4 crores. You see, after in 2016, we have invested 3 crores. So now already after deducting the depreciation cost, we have the profit is this much percent. So that should be segregated as an incentive, and then finally, whatever the condition monitoring tools and sensor and software procured by the organization, you are the owner of this, owner of the vibration analysis, owner of the low oil analysis center, owners of the thermography camera, and whatever this. Just a minute, sir. So last thing is very, very important. So individual monitoring, suppose you have purposed a vibration analyzer, thermography camera, or loop oil analysis, ultrasonic, and instead of installation of IoT sensor. Suppose these things you are using for the condition monitoring to predict the failures in the early stage. So what are the steps? Whatever the condition monitoring tools or diagnostic you use, so first data collection is very, very important. First, data means parametric value, numerical value we will collect. That value and previous value, present value and previous will compare and interpreted. Finally, it will answer analysis. Either your brain software or the software installed with your instrument. Then as a technical, and a manager, maintenance manager, I will go for recommendation and suggestion. If you are depend upon the private party, they will give you a report, and in the report you will find the recommended suggestion. What is the parameter value? What is the machine condition? That will. Okay, sir. Thanking you, thanking all the participants. So I have tried my best to quench your thirst. So time constant, and Atulji is also telling to me. So I think so whatever the portion remaining from my side on Sunday, after vibration 15 to 20 minutes over, so I will take 1 hour and extra half an hour. Taking all these things, I will conclude the our CBM session. Okay, thank you all, sir. Thank you, sir. Okay.
Thank,
So now I am
Thank you
stop
very
sharing,
much.
sir.
I
Stop sharing.
think, yeah,
Now
I can,
I'm
you,
stop sharing.
I can,
Okay.
yeah, you can stop sharing. Thank you, Parik sir. And I think one thing I must say, as tech leaders, no, we have been habituated seeing those jazzy slides, okay, and those presentations and nice jargons. But I must compliment Barik sir that no, in the most simplistic manner, the way you have explained us, I think we are in immense gratitude. These fundamentals of maintenance, we all talk about keeping the lights on, doing something very interesting simultaneously, bimodal IT, bimodal technology. But the fundamentals of maintenance, I think many of us has got a lot of insights today about what maintenance entails, and the due degree of detail. Thankful to you, and I think it will be a great session. We look forward for great sessions in the coming 2 days as well. And before we move on, I would now we would now have this session
Thank
by
you,
Adani
sir.
Wilmer. Yeah, yeah,
Thank you, sir. Thank you, sir. It's my pleasure hearing from you, and
yeah.
you boost my energy for the next session, because
Sure.
we the people are here to serve the industry. Because our okay, sir. Okay, you continue, sir.
Yeah, no, great. Thank you so much. And moving on, I think the next interesting session which we have for today is the practitioner's view. So because so what Barik sir has indicated or has shared in the presentations is about how CBM has evolved over the years. He spoke about the look, listen, feel. He talked about the potential failure and the functional failure aspects. But now we talk about how does it all get deployed? How do we leverage technology, the new age technologies like IoT, and how companies like Adani Wilmer have actually benefited using these technologies for their for driving plant reliability. I would now request Arkadeep Mehta, who's a hands-on operation team members in Adani Wilmer Ahmedabad, which is a part of Adani Group, one of their and I'm sure many of you would know their prestigious customer trusted brand, which is Fortune. We would have all used it also in the earlier years, and even we would be continuing to use that. And about Arkadeep, let me give you a brief. He is an electrical engineer with a postgraduate diploma in operations and supply chain management. He's also a Six Sigma certified business analyst with more than 7 years of experience in process excellence and project management, PMO in India and overseas. And to give you a brief about his role, his work includes exploring, evaluating, and implementing new age technologies to drive process improvement in plant operations and carry out functional design and testing of business process automation and IT projects, particularly in the manufacturing and the supply chain aspect. Joining him, we have Nirmal Parekh, who is the managing director of Alpha Core Tech. He has worked with Dell and has been the executive director of Renoir Consulting and founder and CEO of Percept Solutions. Nirmal brings in around 19 years of deep experience in operations, and he has been engaged in multiple of these smart factory projects, which have led to achieving efficient processes in leading manufacturing companies, including for Adani Wilmer. So I would now request Arkadeep and Nirmal to take over and give your insights about how you have implemented technology in your setup. Go on, please.
Right. Thank you so much, Mr. Atul. This is Nirmal Parekh from AlphaCode Technologies, and we are glad to have Mr. Arkadeep Mehta with us. And also Mr. Abhay Bapna, who is the CIO, is also there on the panel with us and in the forum today.
Wow, that's very good. Thank you, Abhayji. I'm so sorry I missed out. It's a pleasure to have you. Please go on. Yeah.
Right. Thank you so much. And uh, just to start up, we are glad to have Adani Wilmar as one of our clients. So the solution implemented over here is by Infinite Uptime. That's one of the pioneer in the space of IoT-based predictive maintenance solution. AlphaCode Technologies is a system integration firm for Infinite Uptime and puts together the entire solution for the client end as the end deployment and monitoring after sales support. So this is something which puts together the entire value proposition for the client. Today, we are thankful for Mr. Arkadeep and Mr. Abhay to be present in this forum and being able to talk about the value which they are delivering to us and to the client and to themselves that they have valued today. I'll just start up with handing over to Mr. Arkadeep, and if he can take us through what they have put together for the value which is being created at their end, and starting up with a key question: what led Adani Wilmar to consider condition-based monitoring, or what led for them to go into something called predictive maintenance today, being one of the best name in the industry for the FMCG space? What, and having the rich history of the maintenance cycles, and reaching them at this point itself, they have done a lot. You can imagine that they have the largest production of for refined oil in the country. In spite of this, what led them to go into predictive maintenance? Arkadeep, over to you. Can you please take over?
Hello, am I audible?
Yes, Arkadeep.
Thank you, Nirmalji. Atulji, that was a very good introduction of mine. Thank you for that. And it's my privilege to have this opportunity to speak to you regarding our experiences regarding condition-based maintenance. So my introduction is already given. I will introduce to the manufacturing operations which we are into. We are into oil manufacturing, edible oil manufacturing. So there are various operations in the plant area. So there is boiler operations, then there is the expeller operation in which we touch the seed and extract the oil. Then there is a refining operations in which the oil is refined, various kind of refining is done, physical refining, chemical refining, like that. So then there is a packaging operations. So our problem area was there are some operations where the breakdown is more frequent and their impact in the production is less. And then there are areas where the breakdown is less frequent, but the impact is high. So we also wanted to leverage the IoT platform, modern age technology to reduce our spares expenses, then R&M expenses, repair and maintenance expenses. Then we wanted to increase the uptime of this kind of operations. So we came in contact with Nirmalji from AlphaCode. Then we decided to go for a pilot project. We selected two plants. One was Haldia and one was Bundi. Haldia is a port-based plant where majorly refining operations is conducted, and Bundi is a crushing plant where oil is extracted from the seed. So we selected two areas. One was boiler area from Haldia, and one was expeller section from Bundi. So expeller section is very dirty, and it is very it's the wear and tear of the machine is very harsh. So what we did, one was high frequency maintenance, as in the preventive maintenance cost is very high in case of Bundi, and in case of Haldia the cost is less, but the impact on production is very high. So we selected 10 equipments in each of this plant, and we did the project. We are running this project since I think 2.5, 3 months or so, and we were able to reduce the downtime. Then we saved spares cost. Then we reduced the R&M expenses. Then this project gives is, it is a handy tool for our maintenance team. It's a very it's a very interactive kind of platform where a maintenance team can see, and wherever the parameters are growing beyond threshold, it will give you alerts, so that the maintenance team can go and address the issues regarding temperature, vibration, or noise. So our experience is good regarding this IoT based alpha core solution. Then I mean, you can realize the ROI can be achieved in very short time.
Interesting. Okay.
So it's a plug and play device. It gets attached to the vibrating instrument equipment, and it starts giving you the readings.
Okay. And how do you define? How did you define which equipment do we need to? Like you said, there were these frequent failure or the high wear and tear equipments which were there in the expeller section. So was that the only concern, or did you had any other equipments which were critical single line? And how
Yeah,
did
in
you?
boiler section we had a critical line. So we went for high frequency one place and one place high criticality. So two these parameters we
Okay.
looked after.
So one question which is coming out is that no, there are companies who would have older machines. Like suppose you spoke about this boiler, you may have a feed water pump or a ID fan or an FD fan, which is already there in place. So you may not like to replace the fan to make provisions for the new sensors. So were you able to install these sensors on the old equipment, or did you have to replace the equipment also in some cases?
No. In the old
It was
equipment
old.
itself, it can be installed.
So it can be installed. You can deploy it on an old equipment also, or
Yeah.
other. Okay. I think go on, please go on. Anything else you would like to highlight here?
I think Arkadeep and Abhay, if we could talk about see, FFT is one of the key aspects in vibration monitoring, fast Fourier transform, as you understand. But it is a very complex system. So, I'd like to know your experience on the service which you have received on remote monitoring by vibration experts. So, what is your feedback on that?
Yes, the Alpha Core team has CAT2 certified experts. So with looking at the vibration itself, they can tell what kind of problem is there in the motor. So depending on this fast Fourier transform, so it will help the maintenance team to quickly assess what is the problem in the machine.
Another thing is the data which is coming from the machine is like real time. It's nobody saying that okay, I'm getting data in log or anything. Like the data which is coming is the real time where the shop floor supervisor or the engineer knows in advance that something is wrong with the machine. As of now, once the data matures, then you get the more accurate information. But the first and foremost here is getting the alert from the machine that there is something wrong actually, as that's where we find that it helps you immediately to take corrective action and reduce your downtime or spares or repairs and many other things including production downtime and repairs actually.
I think I'm just adding Atul this side. So what I think I'm just highlighting what Abhay mentioned, is that no one is collecting that data, having the right sensors, identifying the right equipment, and getting the right data, and then making sense out of it, and then maybe create a response out of it. So I this the CAT2 level vibration experts are actually continually looking at the data points and giving the right inputs for action and recommendations to the shop floor team. I think that closes the loop, so to say. That's what I, as I understand, is it?
Yes.
Yeah. Okay. Great. Great. Great.
And like
And
even if you think per day, even like even if in a month, if you save 1 hour of downtime, that itself is a huge for continuously where the continuous production is there. It's a huge actually.
correct. And I think there's another question that no that is this how can this help in increasing MTBF, mean time between failure? How can these kind of technologies help in increase mean time between failure?
Because before the failure you are addressing the problem, so the time to failure increases.
Yeah. Okay. So I think if I were to, because no I'm also pitching, because no I've been on the instrument and control side in my initial years, so I know that. So I'm just sharing that no what happens is, if you are able to predict the failure, if you get some kind of signals, a pattern which points that this equipment is likely to fail, then you can take a planned downtime rather than take running it to a breakdown stage, wherein then you have bigger issues and you have production loss. But if you were to do it in a planned manner, then your downtime is also minimized, and in effect your mean time between failure also is increased.
So
Uh,
like few days
one more
back we
point
had
was
a,
Yeah, go
uh,
on.
yeah.
yeah. One more point was like once you have good quality of data, it's a quality of data is good, but um, if you have 3 or 4 months of good quality of data, then the predictive maintenance also it helps you to reduce further predictive maintenance and help you better actually.
Okay.
Um,
So like few days back we had a problem with temperature rising beyond threshold.
Yeah.
So the alert went to all the maintenance team in Bundi,
Hmm.
and they addressed it, and the failure, the breakdown was uh, prevented.
Avoid. Avoid it. Yeah. Okay.
So
I think
we have two questions also from Udit Pawar. He's asking, did this need any changes in the existing PLC SCADA system? And if
No,
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 yes,
no, no,
who
no,
d-
no.
who
no,
did it?
nothing was
No,
changed. Nothing was.
Okay.
it is not using our IT network. It is a separate network which was provided by the Alpha Code team itself. It's a SIM-based internet. It directly communicates with the internet and sends the data to IoT platform, through IoT platform to cloud. So no need of any PLC change or any IT network or anything. It is a very easy to install tool.
Okay.
Directly connects with the Wi-Fi, and straight away you can access the data.
Yeah, so
And
Mr. Rangnath Iyer, he is also mentioning that we are using this solution for more than 12 months in our Vittalpur plant, and it requires only a week to install the system and nothing needs to be replaced. So he is also confirming that. Udit has asked another question. What is the frequency of data point flow? How was the sizing for the solution arrived in terms of network and computing and storage?
As in, at what frequency the data is
Yes.
data is read.
Yes. What is the frequency of data points flow?
I think 5 seconds or 10 seconds. Nirmal ji can correct me.
Half a second. Every half a second, the data is updated in the system based on the current live status of the machine.
Okay.
Okay.
And Deshmukh is asking whether it's on premise or on cloud.
Cloud.
Okay.
No need for so I like to Nirmal Parekh here. I like to add in this. Most of our clients, which we find the plants are in remote location where we don't expect any client user to invest in any high-end systems. Even a desktop is not required. Forget servers. So system is completely end-to-end deployed and monitored by the solution which is provided by Infinite and AlphaCode put together, and the client just needs to give a single phase power supply. The rest all is taken care by us. That's how simply the solution model goes.
Okay. So there is another question: what security has been put in place for this solution, considering the current security scenario?
Very good question. So all the traffic, they only work on the encrypted traffic, this thing which is HTTPS, and it has AES level of encryption, which is the highest standard in the industry or in the security space. So I myself am used to be the security solutions head for some of the largest of banks and mutual funds in the world today. And rest assured, the kind of solutions which have been put together, every protocol which is used in communication is used in an encrypted form, and the entire tunnel is encrypted over AES.
And from the client side, we are not worried about the security at their end, is because it is not connecting to any of our system. It is a parallel network.
Very independently
Very independent. So it cannot access our data.
So, Mr. Abhay, who is the CIO, was also part of the evaluation during the time of the security framework. And that's when this was evaluated very well as per the standards of Adani. And that's when they realized that, yes, it's a very independent running system. And even then, even while being independent, it has all the security, measures in place. Thank you so much.
Okay. Okay. Manoj Kumar asked that whether this solution is applicable to EPC project also.
Effluent.
EPC project, as in the new projects, greenfield projects you are telling?
Yeah, I think he meant that only.
Yeah, new old doesn't matter. If it's a rotary machine, then it can be used.
Okay. Okay. Thank you. Go ahead. Yeah.
I'll just highlight this. EPC stands for engineering, procurement, and construction. So when you are setting up a new project, so there, even for those equipments which are used during the construction phase, you might as well use these sensors to see how well they are performing and how reliably they are performing. Manoj, yes, it can be used. Yeah. Yeah, go on. I think we can. No, I would request Arkadeep or Abhayji, if you can, we can conclude in next couple of minutes, and then maybe Annie, you can conclude with your comments.
So my recommendation will be to shortlist a high
Critical.
frequency area where the frequency of breakdown is more. Then go for a pilot project. Then you can have a rollout in your other plants as well, other areas.
What we are finding currently is now users or shop floor operator or supervisor is saying, yes, this information is helpful. It is giving advanced information, and it's more of a business driven instead of IT driven language.
Yeah. And I think we all keep talking about business alignment, IT business alignment with business. I think this is what is a very useful showcase of how actually technology can align with business objectives and drive and co-create real value on the shop floor. Yeah, I think good. Any concluding remark, Abhayji or
No.
Nitin or? Yeah.
I think it's a simple to use tool with plug and play functionality with data insights and with the analytics inbuilt and additional expertise provided by the team from Alpha Core who are expert in that particular area, which helps. And because to analyze the data, required a help of expert. And initially when you are maturing, this helps the team also, okay, what is the meaning of this or that, because it's not initially, it's little bit learning is required actually.
Sure, sure. Point taken. Point taken. So it's not just about buying technology; it's also about handholding in the initial period, so that one can digest and understand the real aspects and create more value out of it. I think it is
Yes.
perfect. I think thank you Nirmal ji and thank you Abhay for your inputs. And I think good. Annie, if you can please conclude, give your concluding remarks. Yeah.
Thank you, Atul. Thank you, all the participants. Great session, great participation. I think it was a very good exposure, a beginning session, an introduction session to condition-based monitoring, condition-based maintenance aspects. I think ER Barik took us through a very detailed understanding of what are the various modes of maintenance, what is the need for maintenance, what is the need for having an ROI for maintenance. So very, very insightful session and touched upon the condition-based monitoring. We hope the next two sessions, I think the next session is on Saturday, 9 o'clock, and the follow-up session on Sunday, 9 o'clock. Thank you to Amit Saluja for representing NASSCOM here. Thanks, Kamal and Atul, as usual, brilliantly organized. And thank you to Abhay Bapna, Arkadeep Mehta, and Nirmal Parekh for the concluding session. Thank you so much. Look forward to another interesting session next Saturday. Bye, everyone.
Thank you. Thank you. Bye bye. Bye. Thanks so much. Thanks, Annie.
Bye. Bye.
Thanks, Kamalji.
Thanks, Atul.
Thank you, madam. Thank you.
Bye. Bye. Thanks.
Bye. Thank you.